A very good evening, everybody, and welcome to Beyond the Night Sky Discovering the Cosmos. I'm your host, Shaunak, and I'm thrilled to have all of you today here. We are diving into the depths of the universe with an incredible mind joining with us. Please, all of us, welcome our esteemed guest, Professor Abhirup Datta. Professor Datta is an extraordinary figure in the world of astrophysics, bringing together a wealth of experience and expertise. Currently, he serves as a professor in astrophysics, space engineering, and data science at the prestigious IIT Indore in India. Not only that, he has been at the helm as the head of the Department of Astronomy and Astrophysics since 2017, leading the charge in exploring the mysteries of our cosmos. His journey through the realms of knowledge began with a B.Sc in physics honors from St. Xaviers College, Calcutta, followed by an M.Sc in physics from the University of Pune. Professor Datta's career trajectory has been nothing short of stellar. Beyond his current role, he held a significant position as a senior research associate at the Center of Astrophysics and Space Astronomy, University of Colorado, Boulder, USA. Let us not forget his remarkable tenure as a NASA postdoctoral fellow at the same department beginning in March 2011. This has been an absolute honor to have Professor Datta with us today. Professor Datta, your journey through the cosmos of knowledge and your contributions to astrophysics have been inspiring. Good evening and very welcome to this podcast, sir.
Yeah, good evening, Shonak, and it's been quite a pleasure to be on your show. And yeah, I hope we can
Thank you
give
very
more
much.
information about this splendid field of astronomy to the
Absolutely,
young
absolutely, sir.
audience.
Yes, I would say, those who are watching today's video, because already I got a comment coming up from Mansimar Singh. Hello, sir. So I would
Right.
request all, yeah, all of you to have your questions and clear up all your confusion regarding astronomy and astrophysics. He is a very senior person, a very busy person, and because of a reason, that I preponed the schedule to today. Sir, my first question to you would be, obviously we will get subscribers' question. If you can just let us know what is the basic distinction between astronomy and astrophysics?
Yeah, it's an interesting point. I mean, particularly, we have seen astrophysics part of, in our own, curriculum when we try to youngster wants to do an astrophysics. So we mainly come primarily from a physics background and
Okay.
try to understand the laws of physics that governs the cosmos. And so binding laws are mostly from physics, nothing different from that. So that astrophysics term is coined. Astronomy, on the other hand, is essentially observational. So
Okay.
mostly looking at the cosmos, trying to
Okay.
understand the mysteries. So you can say they're basically interlinked. However, if you really want to distinguish between them, the one would be more understanding the basic theory behind the what is happening across the cosmos, and another one is observing the cosmos itself.
Right. Yeah. So thank you. That is a unique distinction. Sir, the question is that when we speak of astronomy as a whole, astrophysics, as you have rightly told, that this is much more related to I mean to say, related to physics. In astronomy, what is the type of mathematics, or what is the type of, I mean to say, technical knowledge that someone should have in order to go more into astronomy?
Uh, yeah, good. So essentially, what the reason we are having a you might know, the audience might not. So we are a separate department. So typically, astronomy or astrophysics is kind of being taught as a part of the physics department. Okay. In our case, this is a separate department of
Okay.
astronomy, astrophysics, and space engineering. The
Mhm.
reason we kind of went forward to become a separate department is the field of astronomy is quite interdisciplinary. It is effectively a combination of natural sciences and engineering both. So the way we put it is that astronomers would like to go after the most faintest signal that can be observed in the cosmos, and for to do that, they have to make the instrument, detector, telescopes to do it. And so the engineers essentially has to come to a rescue to make the finest detectors or telescopes to observe the universe. So whatever telescopes we have been using are all state of the art. That meaning whether it is in optical wavelength or in radio or in other like space-based infrared, UV, X-ray, gamma ray. They're all, if you look at they're all state of the art. We have heard about recently JWST or James Webb Space Telescope. It's a long journey before James Webb actually see the light of the cosmos, but it's been still the extremely uh, state of the art which is possible. We have a giant mid-level radio telescope in our country, one of the largest facility available,
Right.
and they are simply nothing short of miracles, engineering marvels, essentially. So essentially, these two, then you are basically combining the best of the both worlds, science and technology. So it's the background also has to be a little bit more, broad and interdisciplinary. So we welcome students from both science background, mainly physics, because that's the major part of it. Although there are lots of interdisciplinary work now happening in astrochemistry, astrobiology, and we will hear more as you look for extraterrestrial life. Astrobiology segment becomes very, very important as we explore putting human back in space. Astrobiology aspect again become extremely important, human health, etc. So yeah, and from the side of the engineering, it is not only radio engineers but also optical engineers, photonics, and others who mechanical engineers who comes into big play to make astronomy truly a interdisciplinary branch of science and technology. So rightfully we have made it a separate department, and that's the way it should be in general.
Right. Thank you, sir. Already we have got a question from Mansimar Singh. I'm just taking it. Sir, I had a doubt. How could a second year BTech student like me from DTU, Delhi, do a research project at IIT Indore? I'm studying engineering physics and I'm really interested to explore this field. Sir, if you can answer, Mansimar is asking.
Hi, Mansi Maria. So, yeah, we have from this year, if you know, that we have started a BTech program in space science and engineering, first time in India and in any IIT system. We have 20 is the batch strength we have started with. So, this is a very exclusive field for people who are, before that, we have started a minor program in astronomy and space engineering, which is open to any other students of any other majors like electrical, mechanical, computer science, etc. They can take. So there's a concept of minor and major programs, and so a student who is taking any other um, stream, they essentially can opt for few courses to complete a minor degree also in astronomy and space engineering. For students who are not part of IIT Indore, there are options of doing summer and winter projects, internships in house, like in person. We also indulge into online internship, but that was only due to the COVID situation we allowed it. Online internship is a little bit misnomer because it really doesn't make much sense. So we're trying to shy away from hosting more and more online interns, but offline internship is definitely available, and you should contact the right person with whom your interests align, right faculty member of our department or any other departments with whom it aligns, and then you can contact him or her and go ahead.
Right. Thank you. So, Mansimar, you got your answer. If you have anything to clarify, Sir is there, and I think this is a great opportunity to learn from us. Sir, my question to you would be, say, for example, when we are dealing with, particularly with particle physics, say, for example, nuclear physics, say, for example, or general theory of relativity or quantum mechanics, we generally know these are the basic mathematics that we need to know: linear algebra, partial differential equations, may part of differential geometry, probability, statistics, etc. Now, when it comes to astronomy and astrophysics, can you, sir, throw some light? Is there a specific set of skills, or I mean to say, you need to have a knack over this kind of a mathematics visualization or this kind of a thing in order to go into specifically in astronomy or astrophysics? What is the power, or what is the skill that a student should have apart from the basic mathematics which they're done in the graduate or undergraduate level?
Yeah, so I think mathematics and is cannot be compromised at all. I mean, it's nowadays there's a trend. People are doing data science, machine learning, but try to bypass basic mathematics, statistics. That's a strictly no, because it won't serve any good in long
Right.
run. So, so mathematics definitely is required in any branch of science and technology. It's a language which we adapt. So, in particularly in astronomy, we see that apart from understanding of basic physics and physics of the cosmos, I mean, you need to go through, understand, tackle lots of observed data. Or if we are unable to observe that far, we rely on modeling, computation, simulations. And so either way, you have to tackle a lot of data. It's becoming the mostly synonymous with large data sets, big data. Okay. So a common requirement in some sense in this field of astronomy is in order to tackle all this, you need to be good at coding, okay, right? Computer programs to be able to tackle it. But it becomes a little bit, um, quite boring to just keep on doing the same thing again and again. So you need to be a good coder, understand trends of the data, make predictions, forecasting, etc. Remove bad data from good data. Now, what is a bad data, good data? That's a different thing. We can keep discussing that. Um, so I would suggest that the one thing which is we need from students who are coming from basic science background is a knack for coding, a knack for computation, because there is no way if you are coming to a branch of astronomy, you can avoid or bypass the need of coding skills. It's a must almost. So that's a very good thing because when we say that works both ways in some sense, Shona, because because it's a requirement. It also makes our students, when they come out of the other side of the degree, not everybody likes to stay in academics. They want to, for whatever reason, it doesn't pay well, it doesn't, whatever. I mean, or maybe they have lost the need to do more research, or they're not feeling enough motivated towards tackling bigger projects, etc. So they might want to venture into more, more challenging world of corporate jobs. So there are these skill sets particularly, which is required, like coding, understanding some basic statistics, mathematics, is really coming into play. And people who are astronomers are very well sought in financial markets, gas, oil industries. It's very well established. So, and now data science, the new frontier which has opened up, is full of astronomers
Right,
as well as high energy physicists. I mean,
right, right.
I should complement that field also. Yeah.
Yeah. Sir Mansimar is telling that, thank you, sir. Sorry to interrupt you. I already studied about you and DAAC at IIT Indore, also about the radio interferometer at IIT Indore and your projects regarding studying GMRT data. And he also says, I have also mailed you regarding that. If possible, sir, kindly can you consider my request to do a research project under you at your lab? I think this
Yeah,
is
I'm,
good.
if you might have definitely might have emailed me. I mean, if you drop me another one soon, I will definitely respond to that.
Absolutely. Absolutely.
Not
Absolutely.
that
So,
we would not like to, we don't like to respond to people, but sometimes it becomes a little bit out of the bandwidth. So
absolutely. Because
apologies
of
for that.
many emails coming
But
up. Yeah.
definitely I will look into that. Yeah.
Absolutely. Mansimar, this is my success of launching this channel. At least if somebody through my channel can get access to Professor Datta and other speakers, and you can fulfill your purpose, my job is done. So, as sir has told, I understand he is very busy getting huge amount of data. So you need to mail again for that, and I'm sure sir is going to respond. Sir, my next question is, maybe I am making a mistake, so my apologies for that. What I heard is that whenever we are seeing an image, maybe of a nebula or a galaxy or a stars or whatever, it is the drawing that we see in terms of, say, for example, over internet, etc., that horse nebula, this, that, and then it looks like an eye with blue colors, etc. They are actually not that structures, but what the data, as you were telling, through telescopes, etc., what we get are just data. I mean to say, just like heart sign going up and down with some data. Then when we plot it, it is something that we get that kind of a structure which looks like a horseshoe nebula and got a blue stars, red stars, etc. Can you tell me that whatever I have said, is it right or wrong, and how do we actually get to see those data, and actually how the data is being collected?
Yeah. So depending on which frequency you're observing, things can be as simple as, like, you have a camera, like you have a cell phone camera and you're taking an image, and it get processed internally if we don't see all those features, and you finally see an image. Okay. So essentially it's basically that. So for things which are just collecting the photons, we use something called CCD, or charge coupled device, and other similar objects to make it the more sensitive image. Of course, the dimension of the chip, which is at the background of our cell phone cameras, is much smaller than what we use in actual telescopes, because the light is coming from far away distance, and so we need to have a bigger detector or bucket, you can understand, to collect it, to make a sensible output from that. Now, what we collect is photons. Basically, the individual pixels represents intensity. Now, what the true intensity is in terms of colors is kind of a rule of thumb, or some conventions are used. Okay, so like if you have a bluer means cooler, red means hotter.
Mhm.
These kind of distinctions are made. So once the intensity is there, then you kind of do imprint upon that these RGB conventions, how the basic images, color images are displayed, and then that's what we see. So we say it's a false color image. Means
Okay.
basically the color essentially is relative differences between one to the other makes sense, but absolute values of the colors, I mean, doesn't. So you have always, when you see an image, the convention is if you display the color scale also, showing the values for the intensity. It also changes from astronomy from one field to the other. It is more of a trend in radio astronomy that we should show that color bar. Sometimes it is not that similar trend in other branches of astronomy. So it depends. But typically it is. So some information will be there below. If you look at a scientific paper, there is some information given to understand which one is hotter versus which one is colder.
Mhm. Okay, sir. So the thing is that, sir, that means, for example, this Sombrero galaxy or the galaxies, the structures that we see, something is like this, something is like that, something has got blue, as you told, blue stars right at the middle. That means the telescope, once they are taking that picture, is it taking that picture of the galaxy as it is, or it is through data analysis that we find this kind of a picture?
As I said, the relative intensity between the two spots of the same image,
Okay,
they are fixed. They are because of the observations. Now, the
okay, they are
absolute values you imprint upon that is kind of
okay,
sometimes by convention. So whether
okay,
you are starting from a coldest point to be a blue or a black and going up to red or further, that depends on who is doing. There are different color schemes also people uses. We use RGB, we use heat map, we use the cube helix. So there are different conventions.
right.
So what I'm trying to say is that the relative intensities are fixed by as nature is showing us. However,
Okay.
the schemes is at the hand of the astronomers to show it in a
Mhm.
more self-explanatory fashion. Sometimes
Okay.
the dynamic range of the images really matters. So some color scheme is chosen over the other to display that particular feature. The ranges are shown to exemplify certain features which may be dying under the noise. Sorry, under the dynamic range. So you amplify certain sections and you show it so that it makes it clear what we're talking about.
Okay. Okay. Great. Sir, we have got a bunch of questions coming up. I have to take one by one. Now, I will start from the last. Okay. I will take the question of cyber hashtag. He is asking, Professor, my question is how each process happening in the universe is related to time.
So as we know, the standard definition of how accepted picture currently is the universe started from Big Bang, and
Right.
it from there the time t equal to zero truly should be calculated. However, astronomers are peculiar people, so they consider today as a t equal to zero, and we look back time. So we assume that today is the current day. That's t equal to zero, and the universe happened something like 14.9 billion years ago. So that's the current standard. We can't see the universe at a very primordial stage. We can only see up to something called a cosmic microwave background because universe before that was too dense, and if things are too dense, it is also something to something called optically thick. Means nothing is coming out of that which can reach us. So we can only see universe little bit evolved from the still nascent, but not at the birth we cannot see. So things like inflation, grand unification theory, all those are like mostly theoretical models right now because we cannot see and we cannot have evidences of observational evidences of those things happening. So what we can observe is from the time of cosmic microwave background, and then we see the evolution of the universe from there on. So we do discriminate between the very early stars from the evolved stars, early galaxies from the evolved galaxies, etc. So astronomers do use a scale of redshift So as we go looking back and further back, the redshift increases from 0 to 1000 and 1100 beyond. So, yeah, that's one way I can
Definitely.
try to answer your question.
So, cyber hashtag, if you can put your name, I think that will be great because sir has already answered the question. Sir, I have another question from Alpish Srivastava. I think he is asking, hello, I am a MSc astrophysics student at University of Bonn. I think he's logging in from Germany. I am currently working on imaging the Fornax cluster using XMM Newton data. Can you shed some light on cluster scaling relations?
Yeah, I mean, this is probably not a good platform. I study galaxy clusters, and I'm happy that you are studying Fornex. It's a very exciting cluster. Also observed in radio by the Meerkat, and they have a project out of it. I mean, I think if you go into details about scaling relations, and now the other audiences will really get bored.
I
But
think, sir, you can just throw some light because we will all
the,
learn from
the
yeah,
overall thing is that certain things are correlated with certain others. So sometimes we use proxy for one to the other, like the mass to light ratio, for example. So if you have a very strong correlations, you use one of the parameters as proxy to understand the broad range of the other ones. And like for example, we do observe the X-ray surface brightness, and from that we kind of scale what will be the density in the clusters. Similarly, you can derive temperatures, luminosity, but you have to also fit the spectra at some point to get this done. So yeah, I mean there are useful papers out there to define scaling relationships. If you, I'm sure you are aware of it, but if you want to get any, just drop me a mail. We can point you towards that.
absolutely, absolutely. So, Alpish, I think what sir is trying to tell, there's a way, it's a very highly technical discussion, and he has rightly pointed out maybe the others people are not will not enjoy. So, but it is good that you are logging in directly from University of Bonn and Germany. Thank you for this question, and you can contact me. I will share sir's email ID, and it is best that you get in touch with him, and I think you will be you can get a lot of help. So cyber hashtag's name is Satyam Ningam. Okay, I have, sir, one question. Mansimar Singh again. Now he is asking that, sir, I had a question about fast radio bursts. There are some speculations like being magnetars to supernova to kilonovas, but according to you, what can be a phenomena behind it?
I won't take an attempt to do that. I mean, it's still a jury, jury is out there, and it's a fascinating phenomena, and people are observing. There are three or four groups who are dedicatedly working on this. And what you want to see is you see one event, but you also want to see the repeating once before you can at least formulate something. So there are
Mhm.
speculations and conjectures right now about it. How can something is coming in a very flash of things can be so energetic? So what can be the reason behind it? Whatever you've written, magnetars to supernova to kilonova are all one after the others speculations, and because the energetics are quite high, so to explain such a phenomena, and so we have a handful of repeating FRBs, and so that's what it called first radio bursts. So I think we need more, and people are still studying, and they're really doing. I mean, for me to speculate which one of them is there, it will be uh, grossly unfair. And we wait for more evidences to come to a conclusion. But right
Right.
now, jury is still out there.
Absolutely. Thank you, sir. So Karan Alvat has got a question. I think you have already answered the first part. How did the universe begin? You have already explained quite clearly. What is ultimate fate of universe?
Ah, that's a good point. See, we all know that before we talk about the universe's fate, I mean, there will be There are different theories, like there are also theories that it is going through. So as you know, universe is expanding from Edwin Hubble's observations. We know that it's a universe is expanding. There are parallel theories which says we are just caught in the phase of expansion. It may be an oscillating universe going through successive expansion and contraction. There are theories of multiverses, etc., etc. But one thing is for sure that we, I mean, being the life on Earth, depends very very closely on our nearest star, which is the sun. And the sun has its own evolution. So the as it will expand more, and I think at some point the life on Earth may become unfeasible. So that's probably where our part of the universe kind of gets done, but that is still way away from us right now.
Right. And Karan has also one question. What does an astrophysicist do?
Huh. Um, well, I mean, see, astronomy is a fascinating subject. Astrophysicists particularly can do a lot of things what other people also do. Besides but they really do like to find answers to the mysteries of the cosmos. Like we do observe, because on one way we are handicapped that we cannot reach, like in other branches of natural science or even technology. You get a sample, you can bring it into the lab and observe it in situ measurements. It's called in situ because you can have it on right on there. Astronomy is kind of something like a remote sensing, so we are not able to go to our the object which we want to observe. So we rely on the emissions from it or other phenomena related to those. We rely on those and then create a model that what might that object be. A very important aspect of that is, so we human eye is only seeing the light in the visible spectrum. So we are
Mhm.
also, the human eye is also a detector, but it operates only in the visible spectrum, a very narrow part of the entire electromagnetic spectrum. There are other frequencies also, waves, like we talk over cell phones. We cannot live without them right now. So that is not happening in visible wavelength. That is happening in radio. We listen to
Right.
FM transmitters. We see through the dish TVs, etc., etc. So there are other part of the electromagnetic spectrum which we can't see, but that doesn't mean it is not there. And we build detectors around to detect waves, rays in those part of the bands, and we collect information. Same is
Oh,
true for like for X-ray. Like we want to observe anomalies inside our body itself through using X-rays. Similarly, we want to also observe the cosmos in different parts of this electromagnetic spectrum, not only visible lights, but in UV, in X-ray, in gamma rays, in infrared, in radio, microwaves. What happens is that the universe unveils itself in different forms in these particular bands. So supposedly you are observing a neutron star or a galaxy or a particular star. Um, you have to observe the same thing in different wavelengths because there are different physical processes which takes place, manifesting itself at different wavelengths. Some can be in optical, some can be in UV, some can be in X-ray, gamma ray, etc., etc. So unless we collect all the information, we will not be able to make a complete story or complete picture of the source of the cosmic source we are looking at. It's something similar. The analogy we can give is like that seven blind men and the elephant we read in our school days, I guess. Somebody
Yeah.
touching the trunk, somebody touching
Ah,
the tail,
absolutely. Very
and each getting to
philosophical.
the
Yes.
head.
Yes.
So we will keep on talking about the same thing, but we will not be able to come to the same conclusion because, well, that's what it is. And there have been debates where in the past where things have been different because observables are different. So yeah, astrophysicists are the people who kind of brings them together, try to explain with the plausible theory, and the model keeps on changing to fit the observations. If there are new observations which doesn't fit the model, people go back and refine the model. I will not say change, but refine the model to fit the data again. And that's how our understanding of the universe evolves.
Absolutely. Thank you. I would like to make a note to those who are watching. See, sir uses the word refine. That means whenever we are using any scientific term, it is important for us to understand that refinement and change, there is a subtle difference. And, sir, I was making one video that whether we should call a theory to be wrong. Newton was wrong, or Niels Bohr was wrong. Rather than wrong, we should use that word refining, that no theory is wrong. It has got its limitation in its own space-time frame, and from that, things evolve. Sir, Satyam has got one more question. I'm sorry bothering you with many questions. Professor, did any process is observed which is happening independent of time in micro or as well as micro scale?
Uh, Typically, when we are observing the universe and particularly astronomy, it's mostly about macro scale. Okay,
Mhm.
we are not essentially there is no we don't have enough resolution to deal with both the micro and the macro scale at the same time. So, I mean, how, like, supposedly somebody is studying about kinetic theory of gases. There are micro states which, the on symbol of that presents a macro state. Supposedly, you're looking at nano structures. Of course, that will definitely create. But I mean, typically, when we observe the universe remotely, we are mostly looking at the macro scales. Even they're also very difficult. Like, for example, I mean, resolving our own the boundaries of our own black hole and center of our own galaxy has been a daunting task because the resolution required to observe that was quite difficult to obtain. And so it took like the state of the art all facilities in millimeter wave and to create something called a event horizon telescope, and
Mhm.
then first to go about detecting the shadow of the black hole in
Yes,
M87 galaxy, and then come
right.
back 3 years later to do the same for our own galaxy. And so the resolution requirement is quite high to be able to manage this both the micro and the macro scale, because typically what we're looking a galaxy is of the size of few kiloparsec. One
Mm.
parsec is about 10 to the power 18 centimeter. So you can understand. So you're looking at quite different things at the two ends. There is a very famous video in YouTube. You can see the sense of scale going from like maybe a cell in your on
Body,
the
right,
epidermal layers of your body
right.
and scale out and go to the finally the fabric of cosmos. I mean the
Right.
filamentary
Yes.
structure of the web of the universe. That's really, I mean, but getting all of those by a single instrument is it's not
It's
it's
impossible.
really
Right.
complicated.
Absolutely. So Shankojit Singha has got a very, I think it's a pertinent question. He's asking why we only observe CMB as an evidence of Big Bang and why the observable universe is not in radio wave background after a finite distance, it should be Doppler shifted.
Yeah, so CMB is essentially cosmic microwave background. Okay, so you are essentially looking at the higher radio frequencies in some sense. So things do gets red shifted, but we are looking at a very broad, of a feature, and so that's the that's the only evidence we are seeing as the last surface of last scattering, which we say. And after that, we have evidences like right now we are looking into how the universe evolved after that. So there is something which I do is looking into. So as the universe expanded from there, I mean, it became neutral because things expanded, it became cooler, and things recombined. And so it becomes neutral. So it neutral meaning there was nothing, no stars, no galaxies there. So universe stayed like that for a long time. And this particular period, just after the CMB, we see is called dark ages because there is nothing, no light
Mhm.
to kind of no photons, no stars. So there were no photons to light up the entire universe. It stayed neutral, and this dark ages prevailed till the first stars and the galaxies came. The photons were produced, and you can see the universe still again became reionized, and we do see that. So there's evidences of those, and we do look backwards. We know the evidence for the expanding universe exists. Whether it came anywhere other than the Big Bang, I mean, there were other alternative theories which were present, and what happens is there is place for alternating theories, but if there is a solid observational evidence which cannot be matched by the prediction of such a theory, then that theory has to be debunked or said
Okay.
that there's a lack of uh, you know um, flexibility in the model of that particular theory to explain the actual universe. And so there were
Mhm.
competing theories. Then Big Bang, like steady state theory, was there, and they have been sidelined by the Big Bang. Of course, there are still competing theories like it is not expanding, it is expanding and going to be contracting at some point, but we do not have that much of data to support any such things. Like in astronomical scales, things evolves over millions and billions of years.
Mm.
Now, human lifetime is not sufficient to do
Absolutely.
those.
Right.
And yeah, so that's the limitations of that
Right.
kind of a scientific discourse, that we have to rely on what we know, what we have observed. Whether that
Absolutely.
is possible or not, that suppose you have a huge number of sine wave, and you have only data on that specific part where the curve is just rising. So somebody can say, "Hey, it's it's rising."
Mhm.
Somebody can even watch a very small part and say, "Okay, it all looks almost flat." Somebody may get more data and see the rise and the fall, and then say, "Oh, no, no, it's something oscillating." So it depends on the data you have. You rely on that. So as
Mhm.
of whatever is known so far, I think Big Bang is the only fitting response to the theory
Model.
of the.
Right.
Yeah.
Actually. Right. Sir, Satyam has got one more question for you. So he's asking, Professor, it is being globally accepted that Big Bang is the most accepted theory of the proposed theories for the birth of the universe. So my question is that what causes the energy to cause bang? As Sir has told, I think, yes, it is the most accepted model. I leave the question to you, sir.
Yeah. So essentially, we do not know anything before that Big Bang.
Mhm.
Okay. So it suddenly came from, I mean, if you want to explain in layman's language, it came from some, nowhere, and something happened after that.
Right.
and then we see a very um, finite but a non-zero universe, and then suddenly something like inflation happens, which is suddenly bump from a very micro scale to a macro scale
Mhm.
over a very short amount of time, like almost a phase transition. And then we see from there we can again explain by normal physics. So it all is kind of, you can say, going backwards and try to explain what we have seen. There are a bunch of theories, what happened in the first 3 minutes, and that cannot be observed. So I am an observational astrophysicist or cosmologist, so I only rely on what we can observe. Can be in different bands, and so, but theorist's job is a very difficult job because they have to rely on a basic phenomenology and what it suggests. So they come up with different scenarios, and unless it fits the observations, we cannot accept those
Right.
things. They will still remain conjectures, plausible, possibilities among numerous. And yes, bang comes from the thing that, see, so I do galaxy clusters. So clusters are essentially the largest bound objects in the universe. So when two clusters, so clusters have masses like 10 to the power 14, 10 to the power 15 solar mass. One
Mhm.
solar mass is about 10 to the power 31 kg, if I'm right. I think so. Yeah. So a huge number. So when the clusters grows by merging with another cluster, and so when two of these things merge, they throw out a large, huge amount of energy in the intra-cluster medium, basically between the two clusters. And so this energy is you cannot imagine or recreate in just simply in laboratory. You need things like large hadronic colliders to be able to recreate those scenarios. That's why this it's such a big experiment, and where the astronomers and particle physicists came across, and there's a new genre has been created called astroparticle physics.
Astroparticle
And
physics. Actually, just to tell you, sorry to interfere, sir, Dr. Dibanjan Bose from the Satyan Bose Institute, actually, he is coming exactly on next Sunday, 26th of November, to speak on astroparticle physics.
yeah, so it's a new coinage, and it's rightfully so that these things is very exciting, and quite looking forward to.
Right. Sir, before I go to the next question, I have a very special friend of mine, Subhasri, and she is telling that, good evening, sir. I am a teacher of philosophy and I have an immense interest in astronomy. That is why I was waiting for the podcast. So you see, sir, teacher of philosophy also has got a very good interest. So Shubhasri, sir, is welcoming you, and I think that this is a wonderful opportunity. Over to the next question, sir. This is somebody called Mr. Cosmos India. I have a doubt that there is any research program in ISRO for astrophysics.
So ISRO has different institutes. There are two institutes under Department of Science. One is Physical Research Laboratory in Ahmedabad, and they do have research opportunities in astrophysics, and they do take students for PhD. Please go to the website, type in Physical Research Laboratory Ahmedabad, and you will see that. Another institute is there. It's called IIST, or Indian Institute of Science, Space Science and Technology. It's in Thiruvananthapuram, and it also offers PhD, as well as it offers BTech in space engineering technology. And so there are very well established research programs under ISRO or Department of Space as such. Even ISRO themselves have internship programs in postgraduate level, mostly MTechs. Um, I mean, there are several ways you can get attached to that.
Right. So I think Mr. Cosmos India, you got your name. It would be great if you can spell out your name. I am missing one very important question from Brishnu Prasad. So just a second, sir. I just got to this question. Uh, just a second. I want to show this. This is again really, yeah. So, sir, he is asking that, sir, I am a B.Sc physics student. What are the opportunity in career in astrophysics? Can I build my astrophysics career through IIT JAM?
Yeah, so there are multiple ways. Like currently, there are M.Sc physics programs which has specializations in astrophysics and astronomy. Where I did my masters in Pune University, there used to be two papers on astronomy astrophysics taught by Ayuka Pune. It
Mhm.
still exists. Ayuka itself also are about to start something on similar line. I know DU, Delhi University has this option of having a paper or specialization in astronomy astrophysics. There are other IITs where the physics is the major, the MSc in physics, but you can take some number of courses in astronomy and astrophysics. If you're coming in through this BSMS integrated through these ICERs, there are certain ICERs which offers like ICER. I think Pune was offering, ICER Bhopal has offered, Mohali also offers. So this is mostly physics and astronomy, if you see.
Right.
IIT Indore has a MSc in astronomy program, um, purely astronomy, and students from physics, engineering backgrounds are welcome. But you have to come with a JAM score. So the
Okay.
counseling happens on the basis of your IIT JAM physics exam. We are trying to introduce specific papers on space and astronomy, but that will take some time. Till such time, I think physics is the closest we think uh, that is required, and so that's what we take. So yeah, I mean, if you are a BSc in physics, you can aspire for being a master's in astronomy, or you can do astronomy in physics and astronomy in other universities or IITs or ICERs, and that's how you can pursue.
Yep. Sir, a few quick questions. Now, Mansimar Singh is asking, sir, can you shed some light on luminous fast coolers? One such event that I studied about had luminous peak of order around 22, which faded with magnitude of order 2 over 15 days and then vanished.
Yeah, unfortunately, I have no clue about this thing.
Right.
Sorry, we tend to we try to look into broadly everything, but we are very narrowly focused at our research stage and only track things which concerns. Like I'm a cosmologist, so we track those things mostly, but things sometimes like black hole images or like fast radio bursts, those are events out of once in a blue moon, and those definitely interest everybody across the discipline. But yeah, otherwise, yeah, I mean, if you want to know more about it, I mean, I can. If you write to me, I can respond to that. But extempore, no,
Right,
we have to.
absolutely. Sir, Mr. Cosmos is asking, sir, can we propose a new theory by updating the relativity theory regarding the creation of universe? I think he's asking to replace the general theory of relativity with something else.
Uh, I mean, see, everybody is lazy, unless there is a need to replace some theory with a
Mhm.
new one, then only things are relevant to look into. Otherwise, just to have a new theory, I mean, what are the lackings? Why do you think there should be a new theory? What is there which is missing in the existing theory, which doesn't match with any of this thing we are looking into? So that you have to first study before you think of offering a new one. Um, The new one, otherwise the new one will look grossly like the old one. Okay,
Absolutely.
unless there is a need to replace something, it's not a race to do something new.
Right.
It's a
Absolutely.
it's a race to understand things better. So first of all, let us try to observe and know things better, and then see if it is unexplainable using the existing
Mm,
any theories, and then the
absolutely.
need for
Yes.
newer theories comes, and that will happen naturally and more organically
Right.
than a forced proposition that we need a new theory.
Absolutely.
It
Necessity
kind
is
of
the
creates
mother of invention. So that
it's
should be right.
creating unnecessarily crisis out of nowhere.
See, Mr. Cosmos is asking another question. Sir, IISC is good to do a course in astrophysics. Can we directly get absorbed by ISRO or not?
I see do have astronomy astrophysics department, and they do have a joint astronomy program to do PhD. I think there is also doing a BS program in physics, so there must be some special papers in astronomy and astrophysics. I'm not aware, but I mean there should be. I'm just speculating. Whether you can directly get absorbed by ISRO or not, that depends on how you fare in those courses. See, no, a body like ISRO, such a big body, I mean, does not take students particularly from A institute or the institute. So I think you have to also what do you like to do by being in ISRO is also important, and I think you have to crack those. So I would suggest that take up courses which you like to do and which you are motivated to do rather than thinking of whether I will go into this place or that place. That should not be the sole motivation of doing what you want to do. If you like astronomy, just go for it. I mean, there are definitely avenues. See, there are tons of mega science projects that two or three at least India is involved with. So career prospects are definitely there. There are obvious university and IIT ISAs academic jobs are there. There also are non-core industries like data science and other applied areas where you can also partake with your skill sets. So, I mean, I think it's a very good time to be in this particular field.
Right. Sir, I know we are closing about 1 hour, but just to apologies to you, a few more questions. Sir, Mansimar is telling, sir, can you share some exciting projects going on at IIT Indore or in general topics of active research in this field which you know about or working at?
Yeah, I mean, so IIT Indore particularly is involved in few projects like there is India is involved in something called a Square Kilometer Array, one of the largest telescopes underway. It will be built in both. It is split into two continents, one in Western Australia and one will be in South Africa. And so India is one of the participating nations in that. And IIT Indore, our department and our group is one of the part of the founding member of the Indian SK India consortium. So a lot of research is we carry on, which are linked to the SKA project. There are other groups working on numerical simulations. like we are saying Big Bang for a long time. So starting from Big Bang, how the universe evolves, etc. So n-body simulations are a key to understand how things work. So there are groups which work on them. Dr. Suman Majumdar's group. Then the Dr. Bhargav works on magnetohydrodynamics and understanding um, how radio jets are formed. Recently, he's also working on the space weather, the solar physics, and how to understand effects of solar emissions, bursts, etc. Recently, ISRO has a mission called Aditya L1. We're all
Yes.
very excited about it. Uh, it is reaching towards the L1 position between
L1.
Sun
Yeah.
and the
Yeah.
Earth. So people who are interested in sun, solar physics, it's a very golden time to be in India because tons of facilities are becoming
Yes.
available.
Yes.
It's a good prospect.
Yeah.
Going on, there are observational people working on gamma rays. Ramit Shukla is working on the gamma ray bursts and also interested in FRBs and compact objects. Dr. Manonita Chakrabarti is working on that. So there are several people, but also there are people who are working on atmosphere and space weather and working on statistics. Um, there are people who are working on the instrument itself. We're trying to develop. We have a four-element interferometer for mostly for educational purposes,
Mhm.
but we are trying to develop it to be making more meaningful research-wise as well. Dr.
Right.
Narendranath Patra has joined recently, and he's also working on the same. So there is a
Right.
lot of things that are happening. So if you want a specific information, don't feel shy to write to me. It's
Absolutely.
just my first name dot my last name at iiti.ac.in.
Right. Absolutely. So you can get that, Mansimar, from me. That's a very detailed answer. Some quick questions before we wrap up. Sir, Karan is asking that can MSc mathematics students can also work in the field of theoretical physics or astrophysics?
Yes, I think it is possible. Although debate is that you need some basic background in physics. Uh, so I mean you have to cover a little bit more. So if you have a MSc in mathematics, you I mean I'm assuming that you are going to take up theoretical physics or astrophysics in your PhD level. And if that is your question, then yes, it's possible, not impossible, but the effort has to come from the student also to learn a lot of background in physics. Typical theoretical physics will say it's not possible, but I mean mathematics really is a lot of. So you have to have really good applied mathematics skills, and that might work. But I mean, you will really traverse a long distance to catch up.
Mhm.
But if there's a will, there will be a way. That's what I think.
Absolutely.
Nothing is impossible. So I will not
Right.
say no. I will say it will require a lot of work.
Right. So Shankajit is asking, why does the temperature vary in CMB?
So there is a temperature and the global temperature, and there's a variation in redshift.
Okay. Yeah. So that answers your question. Mr. Cosmos is asking, sir, which IIT is most oriented to research field?
All of them. I mean, there is I can't think of any IIT which has doesn't have a research component.
Yeah.
Although they're teaching institute, but it is all the faculty members are devoted to research. PhDs, there are lots of PhD students are coming out of each IITs,
Right.
and so I think it is yeah.
Absolutely. Sir, my last question would be, I think there is another person Satyam, who is retyping me the question. This has come as a very common question from the subscribers, students who watch my videos and channel. If you can explain it a little bit in details. Sir, how to become a theoretical physicist? What are the skills required? What are the steps and how to go ahead in the career? What are the institutes to go and work to become a theoretical physicist?
Yeah, I think there are lots of institutes out there. I mean, Calcutta has a lot of institutes like SN Bose is there. I think there is Bose Institute and SINP, Science for Nuclear Physics. The standard Calcutta University itself has doyens who can guide students in theoretical physics. In order to become a theoretical physicist, I mean, you have to be really have a clarity in physics, undoubtedly. But also, I think you need to have a lot of prowess in mathematics because
Mhm.
that's the language, to do calculations, to do computer. So theoretical physicist also there is a branch like somebody. Not everybody right now still do pen and paper, and there are things which can only be done numerically. So people has to become good computer coders as well, and so that is required. So I would suggest that that's very much essential skill sets you need to if you want to pursue theoretical physics. But Calcutta itself, I mean, there are lots of. It's primarily Indian Association of Cultivation of Science. Another
Mhm.
example in Jadavpur.
Right.
It's mostly theoretical in
Right.
Calcutta.
So,
And
sir,
so,
my
yeah,
question is that theoretical physics has many branches. I mean to say, cosmology is also a part of theoretical physics, etc. So, I mean to say, the students need to select which branch they would go.
of course. I mean, the people are interested in string theory, or people are interested in astroparticle
Astroparticle
physics,
physics. Right.
or particle physics, particularly
Right.
high energy physics, theoretical high energy physics. So it has to be a choice people have to come up with. But I mean, nevertheless, I don't think you can bypass the requirement of a strong mathematics background
Mathematical background.
to do that.
Sir, if you allow me, just last quickly three questions.
Sure.
Satyam is asking that, Professor, there is one famous quote from Einstein: logic will lead you from A to B, but imagination will lead you to anywhere. Do mathematical logic can lead humankind to theory of everything?
Hmm.
Very philosophical question.
Interesting question. Um, I mean, sure. I mean, you need to have imagination because I would say I would answer it a little bit differently, saying that most of the discoveries which has happened in the field of astronomy as well as others, I mean, are kind of happen in a bit of a strange coincidence. I mean, most of them are not what was meant to be. Like you're looking for some phenomena A, but suddenly something came into the data which is phenomena B um, in slightly other part, and you suddenly discover something. So we call it not luck by chance, but I mean we call it serendipity. Okay, so tons of discoveries are mostly serendipitous. So unless people have imagination and can actually you know fit the other things into the model, I mean lots of discoveries were not even possible. So theoretical physicists do come up with different models, and that comes with the imagination, etc. There are in theoretical there is multi-dimensional space is possible. But again, how can you visualize such a thing
Right.
beyond third dimension? And that requires imagination. Like I think I compliment that kind of acumen in people, and that's why we see um, such out-of-box thinking, which leads to a lot of important solutions, discovery, um, etc.
Right, sir. Last two questions. Now, Shankajit is asking: Is time is only illusion? And what is your opinion on Boltzmann brain?
No, time is. We heard about you have heard about this Boltzmann age theorem. So it is a arrow of time, and which says that it goes in the direction where you see the entropy increasing. So I think there is a sense of time. It's not an illusion, but I mean you're caught in the local instance, for example. So we know where we are going. But if you see in a philosophical way, in a broader sense, I mean, there are tons of things which can fit into that. So I mean, we definitely astronomers do need time as a good reference. Otherwise, things won't work. For a space, if you go to ISRO and say time is an illusion, I mean, when you are launching a rocket and when you wanted to land on the moon, I mean, things cannot be illusion. But I
Right.
understand from where you're coming. But I think, I mean, there is definitely a lot of time and it's moving in the forward direction.
Absolutely. Mr. Cosmos is telling, sir, I am B.Sc passed out student. How to build my career to be a best astrophysicist or cosmologist through IIT Jam Physics?
Uh, I cannot answer about the best part
Haha.
truly. I mean, it's
Right.
only you can answer about that. Satyam, right? Or who is it?
Satyam. No, this is
Yeah,
Mr. M. Cosmos. I don't
Jayant
know his
Boston.
name.
But definitely, as I said, we have discussed it before that you can definitely give Jam Physics and apply for M.Sc in astronomy or M.Sc in physics with specialization in astronomy in different IITs. And definitely, you can get a relevant, you know, courses
Right.
covered to start on the path. Now, whether we become based or not, I mean, we don't launch courses to. I mean, what is based mean anyway? I mean, so
Yeah, that is a relative
there are
term. Right, right.
Nobel prizes offered every year. So are you saying that the Nobel Prize this year is not better than the previous year?
Previous year.
So I
Yes.
think those kind of distinctions are immaterial at some point and irrelevant. I mean, you do your job to the best you can, and you are based in your own merit.
Right. Right. Absolutely. Karan Alwat's last question, very interesting. Could there be extraterrestrial life in our solar system?
Why not? In our solar system, evidence is bleak. It's things have been tried on Mars. Doesn't look like there is evidence. The atmosphere is harsh. I think there are Venus missions. India is also planning a Venus mission. So we can have more evidence, but doesn't look like much of a success. But nothing can be said unless it is done.
Yeah.
But extraterrestrial life is very feasible because I mean, as you know, there are a lot of extrasolar planets are being discovered, and planets at the right location from its star, as like we are located from our star, which is the sun. They're also located, which allows them to have their own atmosphere, which nurtures the life, intelligent life. So it's quite feasible. So another thing is that one thing probably we can rule out is existence of intelligent life like humans in our solar system. There can be life in other forms, which we may still have to wait to discover. But intelligent life, maybe you can rule out with the current
Right.
understanding.
Right. So thank you very much. Mansimar is taken. Thank you for hosting this amazing session. Thank you, Abhirup sir. Apologies for disturbing you a number of times. Shankajit is telling, thank you, Professor. Good night. Vishnu Prasad is telling, thank you, sir. And I am telling, thank you very much, sir, because I know you have a very, very busy schedule. I hope you enjoyed this session, sir,
No, I
because
do, I do, I do like to interact with students. We do a lot of outreach also, talking to different students of different phases. Like we often get a lot of requests from school children, class 8, 9. We want to do a project, but frankly, it's not that we are not responding to you, but we are
Yes.
really at a loss that I do not know what project to be given to a class 8, 9 student in
Hmm.
astronomy.
Right.
We have summer interns, and we used to get people from masters, but now people from first year, second year, B.Sc, bachelor's degree, they're coming, and again the same problem. There is a bit of a, so we'd like to interact with all of you more than often. And
Absolutely.
thanks for having me here. And
It's
I'm
my
glad
pleasure
that with
and
some of
honor.
your questions
Satyam is
we
telling,
can
thank you,
dialogue.
Professor, for your valuable time. I would be honest, there is one question. I think you can answer it later. Mr. Cosmos is asking, sir, does entropy decrease inside a black hole?
Adding you right to me, we will
Yeah,
get done within
absolutely.
5 minutes.
Because, yeah, yeah.
Yeah.
So, sir, thank you very much. I think we would again have you if you really have some time because this is a wonderful session. I think all the questions of the students, subscribers, and viewers are answered. Thank you very much for coming to this show,
Thank you.
Physics for Students, and I am actually very honored. So it is a wonderful session. We came to know a lot, and most importantly, lot of career opportunities were being answered. So before you leave and others leave, a small announcement that is on 26th of November, Dr. Debanjan Bose, as sir was talking on high energy astroparticle physics, will be there coming up to talk on astroparticle physics. And on 3rd December, Dr. Sudeshna Ganguly, joining from Fermi Lab, would be talking more about muon G2 experiment and areas in particle physics. And on 25th, I will be having my own free webinar on general theory of relativity. Thank you very much, sir. We are all excited and we are honored to have you here. And may you carry on with your research, and people like you actually bless us. And we are actually honored to have you because we will come to know more through your research. And I think it is a wonderful idea. Thank you very much, sir, for your time.
Thank you. Thank you, Shonak. Good night to all viewers.
Thank you. Thank you, sir. Thank you.
Bye.
Bye.